Hello students. Question part 6 says, write down the values of k for which the line y is equal to k is a tangent to the curve y is equal to 4 sine x plus pi by 4 plus 10. So to answer this particular question, please remember one thing, that the max value of any sine x function is plus 1 and the minimum value of any sine x function is minus 1. So that means if I'm writing the equation y is equal to 4 sine x plus pi by 4 plus 10. So if the max value of sine x pi plus pi by 4 is plus 1, so the value of y that we got is equals to 4 into 1 plus 10, which is 14. And if the minimum value of sine x plus pi by 4 is minus 1, so the value of y that we got is 4 into minus 1 plus 10, which is equals to 6. So k will have two values. One should be 14 and the other one is 6. So you get 1 mark for writing each correct answer for this. That's how you score 2 marks for this question. Now moving on to the B part 1 part of the question, they have asked, show that 1 plus tan theta by 1 minus cos theta plus 1 minus tan theta by 1 plus cos theta equals to twice 1 plus sine theta into sine square theta. So to answer B part 1, we'll first take up an LCM. So if I'm taking up an LCM, so LCM becomes 1 minus cos square theta. That's because 1 plus cos theta into 1 minus cos theta will apply the formula a plus b into a minus b to get a square minus b square. So 1 plus tan theta will be multiplied with 1 plus cos theta, and then plus 1 minus tan theta is multiplied with 1 minus cos of theta. So if I simply open the brackets here now, so it becomes 1 plus cos theta plus tan theta. Now tan theta into cos theta, if we write like this, that tan theta into cos theta. So tan theta can be written as sine theta over cos theta. And if I multiply it with cos theta, so I get it as sine theta only. So tan theta into cos theta, we can write it as plus sine theta. Again, if I open the brackets here, so that's plus 1, that's minus of cos theta, that's minus of tan theta, and that's plus of sine theta again, and the whole thing is divided by 1 minus cos square theta, which is nothing but sine square theta, by the identity that sine square theta plus cos square theta equals to 1. So that means 1 minus cos square theta should be equal to sine theta. So cos theta here gets cancelled, tan theta gets cancelled. So I got 2 into 1 plus sine theta over sine square theta, and that's the result that we are supposed to prove. If I go by the marking scheme, so you get 1 mark for writing this correct. The other 1 mark of using this particular part of tan theta into cos theta is equals to sine theta. The other 1 mark for writing and opening this bracket, so this part for 1, and 1 mark for the final answer. So this is how the mark scheme for this particular question works out. Now if I'm moving on to 6b part 2, so the question says, hence solve the equation 1 plus tan theta by 1 minus cos theta plus 1 minus tan theta by 1 plus cos theta equals to 3 for theta lying between 0 to 360 degrees. So that means we can use this result which we have proved in part 2. So that means we can write 2 into 1 plus sine theta over sine square theta. That must be equal to 3. So that means we are writing about B part 2. So if I cross multiply, so I got 2 plus 2 sine theta equals to 3 sine square theta. So 3 sine square theta minus 2 cos theta, 2 sine theta minus 2 equals to 0. So we got a quadratic equation like this. Now if I need to solve out for theta, so I'll be using the quadratic formula ax square plus bx plus c equals to 0. So the value of x that we get is minus b plus minus root under b square minus 4ac over 2a. So That means if I'm getting, so here the value of A is 3, the value of B is -2, and the value of C itself is equals to -2. So that means the value of sine theta that I'm getting is 2 plus minus root under B square is 4 minus 4 into A into A, which is 3, and into C, which is -2. And that's divided by 6. So the value that we get is 2 plus minus root under, this is 4, and 4 3 12, and this is 24. So that's 28. 4 plus 24, so that's 28 over 6. So if I can take 2 out here, so the value of sine theta that we got is equals to 0.5485. So we just took the negative sign of it because positive value is not valid in the domain. So the value of theta is equals to sine inverse of the given value. So we get two values for theta. One is equals to 213.3 degrees, and the other value is 326.7 degrees. So these two are the valid answers for this particular question. So if I go by the marking scheme, so writing this equals to correctly, we get 1 mark for this. Making a quadratic equation correct, we get, and solving out for this, we get 1 mark here, and 1 mark for writing each answers correctly. So that's how you get a full 4 marker. So if you miss out any one of the solutions, you're missing out 1 mark here. Thank you, students.